Determine the magnitude, direction, and position of the resultant force with reference to point A for the non-coplanar force system shown in figure. Resolving forces horizontally and vertically, summation Fx and summation Fy. Now first, resolving this force horizontally, it will be 45 sin 30 degrees. 45 sin 30 degrees. It is directed to positive x-axis, so positive. Now, resolving this force vertically, it will be 45 cos 30 degrees. 45 cos 30 degrees. It is directed to negative y-axis, so 45 cos 30 degrees directed to negative y-axis, so minus. Now, resolving this force horizontally, it will be 75 sin 45 degrees. It is directed to negative x-axis, so minus 75 sin 45 degrees directed to negative x-axis, so minus. Now, resolving this force into vertically, it will be 75 cos 45 degrees. It is directed to negative y-axis, so 75 cos 45 degrees directed to negative y-axis, so minus. Now, resolving this force into horizontally, it will be 60 sin 60 degrees directed to positive x-axis. So 60 sin 60 degrees directed to positive x-axis, so plus. Now, resolving this force into vertically, it will be 60 cos 60 degrees. It is directed to positive y-axis, so 60 cos 60 degrees directed to positive y-axis, so plus. Now, resolving this, calculating all this, we get summation fx value, and calculating all this, we get summation fy value. Now, resultant is given by square root of summation fx square plus summation fy square. Substituting for summation fx and summation fy values, we get resultant as 65.6 newtons, and resultant direction is given by tan inverse of summation fy by summation fx. So substituting summation fy by summation fx, we get theta 70.93 degrees. So summation fx is positive, summation fy is negative. So we see that summation fx and summation fy r and theta. Summation fx is positive and summation fy is negative. So, and resultant r value and theta, we see that resultant is in the fourth quadrant, as in fourth quadrant summation fx value is positive and summation fy will be negative, and resultant will be making angle with respect to horizontal. Now, we know that resultant is in fourth quadrant, but we don't know where it is exactly. To locate it exactly, we have to take moment about point A, moment of all forces about point A. Now, taking moment of all forces about point A. Now, first consider these two components of 60 kN force. So, now first consider this 60 sin 60 degrees component, horizontal component of this 60 kN force, and say it is line of action of force, and this component will pass through point A like this. So it will have 0 perpendicular distance about point A, and its moment about point A will be 0. So as it is passing through point A, it will have 0 moment about point A. Now consider this component of the force. So now it will have line of action of force like this, and it will pass through point B like this, and it will have perpendicular distance about point A as 3 meters, and it will rotate about point A anticlockwise. So it will have magnet moment of 60 cos 60 into 3. Perpendicular distance is 3 and magnitude is 60 cos 60 degrees. Now, resolving this, considering the components of this force, this component and this component, first consider this component. Its line of action of force is like this. It will pass through point D and it will have perpendicular distance of 3 meters from point A, and it will rotate about point A like this, and its moment is 45 sin 30 into 3 clockwise. 45 sin 30 into 3 clockwise, so positive. Now consider this component. Its line of action will pass through this point B like this, and it will have perpendicular distance of 2 meters from point A, and it will rotate about point A like this clockwise. So its moment about point A is 45 cos 30 into 2, and it will have positive moment about point A. Now consider components of this force. Its components are this one and this one. Now first consider this force component, and it will pass through line of action about point D, and it will have a perpendicular distance of 3 meters from point A, and it will rotate like this anticlockwise. So 75 sin 45 into 3, rotating about point A anticlockwise, so minus. Now consider this force component. So this force will have line of action of force like this, and it will pass through point A like this. So as it is passing through point A, it will have 0 positive distance, 0 perpendicular distance from point A, and its moment will be 0. Now this is coupled having a magnitude of 100 kilonewton meters. So its moment about point A or anywhere, it will be same. So plus. So plus 100, as it is rotating clockwise. So its moment about any point is 100 kilonewton meter only. Now what we have, what is this much, and calculating all this, we get summation MA value, and we get D value, that is D is perpendicular distance of resultant from point A, is given by summation MA by R. Substituting summation MA value and R value, we get D value, that is perpendicular distance of resultant about point A, and x-intercept we get by summation MA by summation Fy, we get x-intercept equal to 0.425 meters, and y-intercept is given by summation MA by summation Fx. So summation MA divided by summation Fx equal to 1.239 meters. So what we have is summation Fx value, summation Fy value, R value, D value, theta value, and D value, x-intercept value, and y-intercept value. So x-intercept is 0.425 meters, y-intercept is 1.239 meters, and D value we got 2.828 meters, and theta value we got 70.93 degrees, and resultant is having a magnitude of 65.6 newtons about point A.